So one of the most important chemical reaction of carbonyl compound is that so haloform reactions, haloform reaction we say. So in order to exhibit haloform reaction, organic compound should have acetyl group CH3 C double bond O, or even sometimes the secondary alcohols CH3 CHOH CH3 also undergoes haloform reaction. The haloform reaction is nothing but oxidation by hypohalides. For example, you take quinone ketone that having CH3CO acetyl group. This is called acetone or propanone. So when this propanone, when treated with this sodium hypobromide or sodium hypochloride, then this acetone transform into CH3 CO minus plus CHBr3. So this is called haloform compound, which is said to be chromoform compound. This is, and chromoform plus water and NaBr are formed. So here CH3CO group changed into oxidized to carboxylic acid, where this alkyl group transformed into haloform compound. CH3 group is transformed into haloform. CH3CO is oxidized. This is oxidized to carboxylic. Let us see the mechanism of the reaction. Mechanism of the reaction. So what mechanism it follows? Let us discuss. So when sodium hydroxide, aqueous solution of sodium hydroxide, react with the bromine liquid, it undergo disproportionate reaction. We get NaBr plus sodium hypobromide we get plus water we get, right? The sodium hypohalide, this is sodium hypobromide, is more reactive. The sodium hypobromide react with this ketone, and it can convert the ketone into carboxylic acid and chromoform compound. Let us see when secondary alcohol like CH3, C secondary alcohol, propanol. When propanol is treated with NaOBr, friends of base, sodium hypobromide, then secondary alcohol can transform into, can change into ketone. Ketone, it can changes. It can changes into ketone. It can changes into ketone. Then the ketone will undergo oxidation to form CH3 COO minus plus CHBr3. So let us look this reaction, how this ketone transform into, you take ketone that containing CH3CO functional group, and this will interact with the base. The nucleophile of the base abstract the proton from this carbon, alpha carbon, and transform into CH3CO CH2 negative. Then water molecule is formed. So once this CH2 carbanion is formed, so this will interact with this hypohalite or sodium bromide, because the bromine in hypohalite has the positive charge. So then the addition to this carbon, this bromine electrophile added to this carbon, then we can get CH2 Br is formed. So in similar manner, in the presence of one more BRO minus, it has bromine plus charge. So then twice electrophilic substitution reaction takes place here. 2 hydrogen atom replaced by the Br. Then it can transform into CH3C double bond O. CBr3 is formed by the electrophilic substitution reaction here, electrophilic substitution reaction. Since CBr3 is best leaving group, and when this compound treated with this nucleophile, the nucleophile attack this carbon, electrophilicity carbon, since this pi bond moving on to this oxygen, and CBr3 is the best leaving group at a time. Then this compound transform into CH3CO CH3COOH carboxylic acid is formed, plus CBr3 minus is formed. Then the next step, the carboxylic acid CH3C double bond OH loses proton Br3. Now carbon is halogenated, it has negative charge. Then one of the proton, this proton shift from this oxygen to this carbon. Then this CHBr3 bromoform is produced here. Tribromomethane is formed. So then CH3 COO minus carboxylate ion is formed. So this is a mechanism involved. So in that haloform reaction, we say, if you take chlorine, we'll get chloroform. So instead of bromine, if you take sodium hydroxide plus Cl2, if you take, we will get sodium hypochloride, we get. Or when NaOH plus iodine, if you take NaOI, sodium hypoiodide, we get. So this is oxidizing agent. So, and this iodine and chlorine or bromine added to the carbon by electrophilic substitution reaction method. Electrophilic substitution reaction method. I hope you understood this haloform reaction. So, and organic compounds having acetyl group CH3CO will undergo haloform reaction. Thank you.